Okay, so welcome to our lesson today, and today we are gonna talk about simplifying complex fractions. We have been actually working with rational expressions and fractions for the past, I would say, 2 to 3 weeks, and this is not like anything new, but more of like a continuation with some like more complex things. So our aim for today, like I just said, that we are gonna be working with simplifying complex rational expressions, or in other words, fractions. I have a do now for you guys in here, and I'm asking you guys to simplify the three complex fractions I have in there. They're not as complex, I would say, just because you're working with numbers and not any variables. So try to do these three problems. I'm gonna give you guys about 6 minutes to do them, and when you are done, chat box the answer. You can private message me or Meherin, or public message, it doesn't matter. So how do you actually, I did not actually tell you guys about doing this kind of simplification before, but how do you like simplify this? Well, I mean, you can obviously use your calculator, but do not do that. Try to do it like manually without a calculator. So the way you kind of go about it is that,
Can I say it?
say that one more time.
Can I say it?
Yeah, sure.
Wait, I'm not sure, but like I think you subtract 3/4 with 3 minus 2 first. Then after you get that one, you divide it with a 4 and you get the answer. Right?
Well, yeah, you are on the right path. So what you have to do is that you have to simplify the bottom first. So the denominator, it needs to be simplified. You have to make these two fractions. So the thing is, you already have like this is an entire fraction. And in that fraction, you have a numerator, which is just a number, and the denominator already has two fractions. So it's like a fraction within a fraction, or like fraction within like couple of fractions. So then in the denominator, you again have a numerator and denominator. So it's kind of like complex in that sense. But what you can do is that you can combine them. So you can make those two fractions into one fraction, so combine them. And after you are done combining them, you have to like divide fractions. And the way you kind of divide fraction is that I told you guys about this, the keep, change, flip thing. So you keep the top, you flip the sign, so you keep whatever is in the top, so 4 stays there, and then the division becomes multiplication, and whatever you have in the denominator, that gets flipped, right? So let's say you had in here, you had, I would say, I don't know, x over y, that gets flipped into y over x. So keep, change, flip, or in other words, you have to multiply the numerator using the reciprocal of the denominator. That's one of the ways to do that. There's actually another way to simplify this kind of complex rational expressions or fractions. Try to do whatever way you know right now, and obviously chat box the answer, and after that I'll try to like talk about it and then tell you guys that there are actually two ways that you can approach this problem and do this.
Wait, I got a whole number.
You can get a whole number, it doesn't matter. I mean, sometimes fractions simplify to be whole number. You know, technically whole numbers are also like fractions. You can put a 1 in the denominator and that also becomes a fraction. So it's okay if you get a whole number. So wait, so -5 times 1/3?
Negative
Or
5 whole 1/3.
oh, so you turned that into a mixed fraction, right?
Yeah.
Which
It's
is
called mixed
correct.
fraction.
That's the correct answer. Yep, you're correct. So
Okay.
yeah, so that is actually -16/3, right? But then you turned that was actually, yeah, you turned that into a mixed fraction because that was a proper fraction, and you can always turn proper fractions into mixed fractions. Yep. Yep, that is correct, Maggie, except it should have been -5. All right, so let's do number 1, actually, okay? So for number 1, what we are going to do is that what Jerry told us, we are going to simplify the bottom first, the denominator first. So whatever I'm doing, this is actually one of the ways to actually do that. And then there's like another way, which I'm going to talk to you guys in a little bit. So I got 4 over, and then when I'm trying to simplify that fraction, what I have to do is that I have to find I have to do the LCD, the least common denominator. So I have to create common denominator for them. So for 3/4, so I have 3/4 minus 3 times 2. So I'm going to multiply the top and the bottom using 2. So then once I do that, I have 4 over, so then I have 3 minus, so what I did was like I created the common denominator. So now both of my fractions have the same denominator. And once you see that, what you can do is that you can just bring the numerator, the tops down. So when you do that, you bring down 3, and then in here you multiply across, and then you have 3 times 2 is 6. So then you simplify the bottom again. 4 over 3 minus 6 is actually -3, and you have the 4. And now what you can do is that you can do the keep change flip thing, where I'm going to keep the 4, change the division sign into multiplication sign, and I'm going to flip the fraction. Remember, I still need to have the negative sign in there. So I'm going to flip it, or I'm going to put the reciprocal of the fraction in there, which is 4 over 3, right? And when you do that, you have to multiply. Well, I mean, if you take a look at it, you can't like simplify them anymore. All you can do is that you can multiply across. So you multiply the top, and then you multiply the bottom. Well, in the bottom in here, you actually have like 4 over 1. So you can multiply them, and you can multiply the top. Well, 4 times -4 gives you -16. And 3 times 1 gives you 3. And then you guys turn that into mixed fraction, which you can absolutely do. -5, 1/3. Yeah, or you can leave your answer in this form, like the proper fraction form, or you can do that. There's another way technically to do this problem, and I'm gonna show you that way. So just remember that what was our LCD? Our LCD was 4, right? From whatever we just did, our LCD was 4. That was the least common denominator from all the fractions we have, right? So if that is the least common denominator, what I'm gonna do is that, clear, I'm gonna multiply everything in there using 4. So I'm gonna multiply 4 using 4. I'm gonna multiply this fraction using 4. And I'm gonna multiply this fraction using 4. And what happens when I do that? 4 times, so in the top, 4 times 4 gives me 16. And in here, if you multiply them, right? So this 4, they'll cancel out. You will be just left with 3. And in here, 2 and 4, you can cancel out because 4 divided by 2 gives you 2. Look what you just did. That whole like fraction on top of a fraction just turned into one fraction, right? And then now you just simplify that. So 16 over what is 3 minus 6, that's -3. That's the exact same thing you had before. So now if you want to turn that into mixed fraction, it's going to be -5 1/3. Did that make sense? Did you guys see how it was like, okay, so from whatever I was given to like automatically to my answer kind of? So you don't have to do all those steps in between where you like you combine the top, not combine, you simplify the top, simplify the bottom, and then you keep change flip, find the reciprocal, multiply across, get your answer. You guys can do this one too. But in this case, you have to be able to identify what your LCD is, or least common denominator is. In this case, it was 4. Yep. So we're gonna go back. And we'll continue with number 2 and number 3. It does not matter actually which way you want to follow or which method you want to follow. As long as you get to the right answer, you are good. Do you guys have any questions? Are you guys stuck? Confused? Please, please, please talk to me if you are.
I'm not confused.
Thank you for letting me know that or confirming that. So then try number 2 and number 3. So again, for number 2 is a little bit more complex than number 1, just because you have to simplify the top, you have to simplify the bottom individually, and after you do that, you get to like do the keep change flip thing, or you multiply the numerator using the denominator, the reciprocal of the denominator. But before you get to the point, you have to do a little bit more work. Or if you want to use that LCD method or the second method that I talked to you about, the LCD in here is like super easy because you just look at the denominators. How many denominators you have in there in your like separate smaller fractions? Because like this is your one major fraction, right? This is an entire fraction. And in that entire fraction, you have smaller fractions like this one, this one. And well, in those smaller fractions, I only see 2 denominators and they're the exact same denominator. So guess what your LCD will be? I'll to try that one more time. All right, so let's go over number 2. Zara, do you need more time or you want me to go over number 2?
I need more time.
All right, so I'll give you 1 more minute probably, and then we're gonna go over number 2. For number 2, actually, you are when you simplify actually the simplest answer that you have or your final answer, that is supposed to be an improper fraction. So your denominator will be bigger than your numerator. The
Wait, do I
top,
simplify it?
yes.
I simplify.
I mean, yeah, you have to simplify. So when you get a fraction as your answer, right? And if you see if you can simplify the fraction, simplify it. And if you cannot simplify it anymore, then that is your answer. Oh, that is. All right, so let's go over number 2. So this is our number 2, and it looks like a long journey because I have a top and I have a bottom, and I have to simplify both of them before I get to have them into one fraction, okay? So what I'm gonna do is that I'm gonna do it in here. So I have 1, and then I have 2 over 5, right? So what do I do to the top so that both of those fractions will have the both denominator? What I was actually asking you is that you have this, right? You have 1, but technically you have 1 at the bottom too, right? So if it's 1, you know that there's always a 1 in the denominator. So I can write it like that. And then I have 2 over 5. So if I multiply the top and the bottom of this fraction using 5, now do I have the same denominator for both of my fractions? Yes, I do, right? 1 times 5 gives me 5, and then I have 5 in there, so now I have the same denominator. And then what I'm going to do is that I'm also going to do the same thing to my bottom or the denominator in here, so that I'm going to write them in like fractional form first. You know how like underneath 2 you always have a 1? There's always an invisible 1 underneath a whole number. So then we have that. And now I know that if I multiply the top and the bottom using 5, I just created common denominators, right? And once I do that, now so now, okay, do not look at the bottom now, right? So we are just working with like this part. We are just working with this part. So whenever I'm telling like denominator, whenever I'm telling like numerator, I'm referring to this blue box. Okay, so now I have the same denominator, so then I'm going to bring down the denominator, and then I have 5. 5 times 1 gives me 5 plus 2. We are done with the top. Now we're going to work with the red box, right? So then now in there, if I'm trying to combine them, it's going to be, so I have to multiply across. 5 times 2 gives me 10, and then I have the same denominator, so obviously that is my common denominator, and then plus 3. So now you combine, you add the numbers. So again, whenever you're trying to do this, do not get yourself confused, because try to work like separately, but then try to also work like, so try to like work correspondingly with whatever you are doing. So whatever you do to the top, do that to the bottom too, even though you're working with like fraction on top of a fraction like beneath a fraction, kind of like that. So I'm gonna combine them, right? So 5 plus 2 gives me 7 over 5, and then the denominator, 10 plus 3 gives me 13 over 5. And now I can do this. 7 over 5, which is my numerator, and I can multiply that using the reciprocal of my denominator, right? And when you do that, what do you see? You have 5 in here, you have 5 in here. So you can cancel them out. You can cancel stuff diagonally when you are trying to multiply fractions. So then now I'm just left with whatever I'm left with, and multiply across. 7 times 1 gives me 7. 13 times 1 gives me 13. That is the final answer. 7 over 13, which is why I said it's an improper fraction, because you cannot change this into mixed fraction. So that's your answer, actually. Do you guys have any questions? No? Okay. If you do not have any question, I want to show you the other way that I was talking about, the LCD way. Notice how in here your LCD was what, 5, right? In this method that you just did, it was 5. Even if you did not do this, just by looking at it, you can tell that, oh, if you only look at the smaller fractions. Do not take a look at this entire fraction. So if you take a look at the smaller fractions, in this fraction you have a denominator of 5, and in this fraction you have a denominator of 5. So your LCD is going to be 5. And like we did before, what we did was that we multiplied all of them using the LCD. So if I multiply 1 using 5, if I multiply this fraction using 5, multiply this whole number using 5, and this fraction using 5, what do I get? So if I do this part, 1 times 5 gives me 5. And if I take a look at this part, if I'm multiplying that with 5, this 5, those 5s, they cancel out. So I'm just left with 2. If I take a look at this part, 5 times 2 gives me 10. And if I take a look at this part, these 5s, they cancel out and I'm just left with 3. Did you guys see how this whole thing turned into this thing? And we did not have to go through that whole process of like having to add a fraction in the top and having to add a fraction again in the denominator and then do like the reciprocal and multiply that with the numerator. No such processes. So now we do that. Now you just simplify. 5 plus 2 gives you 10. 5 plus 2 gives you 7. What am I saying? That gives you 7 plus 10 plus 13 gives you, 10 plus 3 gives you 13. Do you guys see how that is the exact same answer? And it took us only 2 steps to do that. But like I said, whichever way you are more comfortable, you can obviously do that. But there are actually 2 ways. We're going to go more in depth.
Wait, can you go
lesson.
back again? Like,
yeah, sure. So this is going to be our lesson today, but I'm like almost like telling you over the do now, but this is actually our lesson. We're going to learn about this more in depth actually in our lesson.
I'm done.
Thank you for telling me that. So we go back and try the third problem or the last problem in the do now problem. And I'm going to give you like actually 1 minute, no, like 2 minutes to do that problem. So this is actually going to give you a weird looking answer.
I have a question. The
Yep.
denominators don't match. Then what do I do?
What do you mean? So like 25 and 16?
Yeah, so like you did the LCD thing where like they both had like 5 and you used 5 on like to do like the cutting thing where you cut the number.
The cutting thing. Okay, so if you are trying to follow that method, what you should be able to do is to find the LCD. So you take it the smaller fractions in here, and you kind of like have to figure out what the LCD is from those smaller fractions.
Wait, LCD is least common denominator?
Yep, it's the least common denominator.
Never mind. I get it.
Mm-hmm. Please let me know if you're stuck, if you're confused, or any such thing.
I'm stuck.
Okay, hold on, Maggie. No, sorry if I did not call you Maggie. I was Maggie private chat me something and I was like trying to respond to that.
Yeah.
But it sounded like, I called you Maggie.
No, it was alright. I got you.
That is correct, Maggie, except it's negative. Oh, you did. Oh, okay, you did the negative thing. Yeah, so that is the correct answer, Maggie. You did it correct. You want to walk us through? Like, you want to help me out by telling me the steps?
So do I just say it?
Yeah, you can say it, and then I'll be your pen. So whatever you tell me,
Okay.
I'll write that.
I'll try.
Mhm.
Okay, so first you find out the denominator, so you multiply 25 2 over 25 with 16 over 16 and minus 5 over 16. You have to multiply that by 25. And
Yep.
you'll get 32 over 400 minus 125 over 400.
Mhm.
And once you simplify that, it's going to get you negative 93 over 400.
Yep.
So we have to keep change flip. So
Mhm.
4 over 5 times 400 over negative 93, which
Mhm.
will give us 1600 over negative 465.
So yeah, so that actually can be. So what you said was that? Negative 1600
Yeah,
over 465. So this can actually be simplified. I mean, you can actually simplify it from here. You know that you can divide 400 by 5. I mean, yeah, 400 by 5. 4 times 8 gives you, 5. So you can simplify. Okay, so you can actually divide 400 by 5. So 5 times 8 gives you 40. So that's actually 80. And now you can like cross multiply. Not cross multiply, like multiply across. So then, yeah, so you can either do that or you can come up with this fraction first and then you can simplify that. And the simplified answer is supposed to be negative 320 over 93. So in other words, you can simplify it from here. I recommend you simplify from here rather than from this fraction, because if you try to look at this fraction, you have 1600 and you have 465, like two big numbers. You can simplify it from here. If you do that, if you multiply across, 80 times 4 gives you 320, and then 93 is just 93. So good job, Maggie, and thank you so much for participating and then helping me to walk through. Do you guys have any questions? Or do you have any questions?
No, I'm just like looking.
We have
Okay,
to now. Oh,
alrighty.
sorry.
Okay.
Let me just write it here in case you ever feel like to use the other method. So you have to multiply everything. Oh, I should have used a different color actually. You have to multiply everything using 16 times 25, and I recommend not multiplying them and making it 400, because then you're just doing extra work. Just keep them simplified, like 16 times 25. Sixteen times 25. 16
Alright, I'm done.
times 25. And in here, it's also like 16 times 25. You have to multiply everything using 16 times 25. And once you do that, you would actually be able to simplify this entire fraction into a nicer looking fraction with only one, like a whole number in the denominator and a whole number in the numerator. So we're gonna go more in depth using our lesson today. So we are gonna, whatever you guys just did, they were all complex fractions. So like the definition in here states, complex fractions that have denominators. So you have a denominator this is your numerator, right? And this is your denominator, and which makes it a fraction. But if you take a closer look, in that you have a whole number, and you also have a fraction which has another denominator and another numerator, a denominator and numerator, right? Which is what makes them complex, because you not only have a fraction, but you have fractions within that fractions, right? So you are working with multiple fractions at the same time. So that is basically the definition of a complex fraction. And what I'm going to do is that there are actually two ways to do that. And it sounds like you guys already know one of the ways, because you needed to know. So the way that you guys tried to do it in your do not problems was this one. And then the way that I talked about is the other method, which is method 2. But you guys already know this one. So if you feel overwhelmed by the wording or the example in here, please do not feel that way, because you just used this way, or you just implemented this method to do the do not problems. It is not any more complex. Do not feel overwhelmed, okay? So what you do is that you guys did create a single fractions in the denominator and numerator, right? So you were given, like, you were adding two fractions in the numerator, and you did combine them by finding the common denominator. You did combine them into one fraction. So what we are gonna do with this rational expression? Ooh, fancy, fancy. So, you know, you guys worked with this, like 1 plus 1 over x, how to add rational expression. You guys, obviously, the best teacher in the world taught you this, right? So if you know that, you do that. You add the top, you add the numerator. So whatever fractions you have, you add the fractions. And how do you add? You obviously create your common denominator. So in order for me to create common denominator, I have to multiply the 1 using x. So I have to multiply the 1 using, like, the denominator and the numerator using x. So in that way, I have created a common denominator of x and x, right? And if I multiply across, which is what this example did, so if I try to, like, multiply across 1 times x, gives me x. So boom, I created common denominator. I have x over x plus 1 over x. So I'm done with the top. Check. Now, if you take a look at the bottom, you are actually subtracting in the bottom. And subtracting is actually the same thing as adding, except you have a subtraction sign. So again, you have to create common denominator, and then in order for you to do that, you have to multiply 1, and you have to multiply the top and the bottom of 1 using x squared, because that was the denominator of the fraction that you had in there, right? So if you multiply the denominator and numerator of 1 using x squared, you have the same denominator. Take a look at here, right? And now if you multiply across, you get x squared. There you go. You just, like, created common denominators for the fractions in the top and the fractions in the bottom. Notice how you're doing the exact same thing, but you're just doing that twice. You're doing that once for the top, once for the bottom, but you are doing the exact same thing. So in that way, you can keep track of your steps and how you should be doing the same thing to the top and the bottom at the same time. Okay? So once you do that, you have the same denominator, so xx, it obviously comes down to be x, and you just add the top. So it comes down to be x plus 1, like it says in here, right? And then in the bottom, right, you had all that fancy stuff. So then the denominator was x squared. So then I bring the denominator, which was x squared, and then whatever in here it was x squared minus 1, and I wrote that in there. It's x squared minus 1 over x squared. So now you are in this step, and now you have a fraction, and that is a fraction again, right? So it cannot get any more complex, like, okay. And once you do that, then you apply the division rule of fractions. So what is the division rule of fractions? It's nothing fancier than KCF, keep, change, flip. So you keep the top, we kept it there, you change the division into multiplication, which is what we did in here, and you flip it, you make it the reciprocal. So the denominator becomes a numerator, and the numerator becomes a denominator. Once you do that, it's the same thing that we did. We learned about multiplying rational expressions, right? So once you do that, how do you multiply rational expressions in this step? Well, you multiply rational expressions by looking for common factors, right? So right now, I do not see any common factors for x squared minus 1. Well, how can I see that? I mean, it's not factored. Hey, factor this. Well, once I factor this, so this x squared minus 1 is actually Dot's difference of two perfect square because 1 is a perfect square. So that turns out to be x plus 1 and x minus 1, like it says in here. So once you factor that, you are supposed to see the common factors. Boom, you cancel them, and whatever you are left with, you multiply across. But notice how you have an x in here and you have x squared. They can be canceled because you have two x's at the top, one x at the bottom. So cancel one of the x's using the exponent. So now you are just left with x here. I'm gonna use a different color. You're just left with x here and x minus 1 at the bottom, which is what it says in here as the answer. I know what you guys are gonna tell me right now. Like, what in the earth is this gift? Well, this is why it is complex fractions. So the main thing in this is that it combines every single thing we learned before. It combines how to add fractions, how to subtract fractions, how to divide fractions, how to multiply fractions, how to simplify fractions. It composes every single thing that we learned before regarding fractions: multiplying, adding, subtracting, dividing, simplifying, factoring. So every single thing that we have learned so far, you have to apply all of them in this one problem to simplify this, right? So this is one of the ways that you can do it. I mean, obviously the last step that I did not talk about was to simplify if necessary, which is what we did in here actually. So the other step, which I think is much easier and less complex, as you can already tell them by the number of steps, we did 1, 2, 3 steps only to do that problem. So it is actually the same problem that we just did. Well, not the same problem, but yeah. So what we are gonna do is that we are asked to also simplify this one, but this is known as another method. So the first step in this method is to find the least common denominator, or the LCD, for all the denominators in the complex fractions. So you have to find the least common denominator for all the smaller fractions that you have in the bigger fraction. Yeah? So when you do that, when you find the LCD, so your first step is to find that. And while you're trying to find the LCD, you don't actually have to show your work. You can either do it mentally or just do it in a piece of scrap paper or at the side. And once you do that, you have to multiply all the denominators and numerators using the LCD. So you multiply this one using LCD, you multiply this fraction using LCD, this fraction, not fraction, but this number, and you also multiply this fraction using LCD. Everything you have in the bigger fraction, you have to multiply everything in there using the LCD. Yeah? And when you do that, you're supposed to have your answer. What was I even talking about? Well, if you take a look, what is the LCD? Try to look at the denominators that you have in there. What is the LCD of?
Oh, you meant what the number?
No, okay, so yeah, you can think of 1 as having a denominator of 1, or you cannot just take that into consideration. You can just leave that out. You take a look at x and then x squared. What is the least common denominator of x and then x squared? Remember, when we were trying to do the greatest common factor, there's a difference between the so we were working with the greatest common factor, the GCF, and when we were trying to do the GCF, we were talking about, okay, you always pick the variable with the lowest exponent. That is not the same thing as the LCD. So your GCF is not the same thing as your LCD. In your GCF, you pick the denominator with the lowest exponent, but then for your LCD, what do you pick? if you are working with the same variable but different exponents, you pick the variable with the highest exponent. That's your LCD. And once you figure out the LCD, you multiply. So in here, the example that I showed you in here, they multiply this entire thing, by which they mean is that they're multiplying 1 using x squared, and they're also multiplying 1 over x using x squared. They're just like a more efficient way of like to show that. But to break it down, like I was like doing it before, you multiply 1 using x squared, because that was the LCD. Multiply this using x squared. Multiply this using x squared. This using x squared. And what happens when you do that? 1 times x squared gives you what? X squared, right? And then if you try to take a look at this, you can cancel out the x at the bottom with one of the x's at the top. And then what are you left with? You're just left with x. Right there. Boom, done with the top, right? And then if you take a look at the bottom, 1 times x squared gives you x squared again, right? This thing. And negative 1 over x squared times x squared gives you what? Negative 1. Because this x squared and then the x squared that I wrote in there, they cancel out. Did you guys see how you just turned that entire complex fraction into, so this entire complex fraction into this thing? Nice, simple one fraction. And then from there, you can obviously simplify them by using factoring. Factor the top, factor the bottom. You can factor the top using GCF. So your GCF was x. And once you figure out the GCF, you divide each of the terms using GCF. X squared divided by x gives you x. So, and then x divided by x gives you 1. Right? And then if you take a look at the bottom, this is dots. So then that should be x plus 1. X minus 1. I mean, they wrote it the other way, x minus 1, and then x plus 1. And once you do that, you look for common factors and you cancel them out. Boom, boom. That's your answer. This is actually a much simpler way, only if you're able to figure out the LCD. Do you guys have any questions so far? I'll take that as a no. And if you guys don't have any questions, we are gonna do, guess what? Exactly. We're gonna do practice problems. They look so amazing to me. I cannot wait to do them. So try with the first one. Try the first problem. I'm gonna give you no more than 3 minutes. So after 3 minutes, we are gonna go over them and try to do that. Private message me the answer or Meherin the answer, or you can put it in the public chat as well. So try to do the first problem and let me know the answer. Please, 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 please talk to me if you're confused, if you're stuck, if you need some clue. There are like literally 2 people sitting here to help you at any moment you want. So please take advantage of that and ask us if you need any help.
I'm confused and I'm stuck.
Okay, so the first one is actually easy because in here, you don't have to, so you see how in like this one, you have to like combine. In here, they already gave you like a combined form, but it's just like a fraction on top of a fraction. So this is the first problem. So you can do it like I said, like you can do it like 2 ways. You can either do it the keep change flip way, because you don't have to like combine anything in the top or combine anything in the bottom. You just have to multiply the numerator using the reciprocal of the denominator. You can absolutely do that. When you do that, it becomes this, right? And when it becomes that, what you do is that you look for common factors. Do you guys see any common factors so far in that?
N minus 4?
N minus 4 is a common factor, but because now that you have like, can you cross N minus 4 out?
No.
You can't cross them out because when you are trying to multiply fractions, you cannot cross things out across. So if you cannot cross things out like this way. So this is the horizontal way. You cannot cross things out horizontally. You cannot. So you can cross things out diagonally. You can cross things out vertically, but not horizontally. You cannot do this. Like, nope. Right? So we cannot cross N minus 4 out. What we have to do is that we have to multiply across, because this has no like common factors that we can cross out. Okay, so let's multiply across. So what is m squared times m? M squared times m is m to the third, right? And we did not cover exponents yet, but when you are trying law of exponents, but when you are trying to like multiply, so when you have the same base and you are trying to multiply the bases with the exponents, you keep the base and you add the exponents, right? So your base was m, you kept the base and you add the exponents. So 2 plus 1 gives you 3. And now in the top, what you have to do is that you have to FOIL them, right? So what I'm going to do is that n times n gives me n squared, n squared, and then n times -4 gives me -4n, and -4 times n gives me -4n, and -4 times -4 gives me +16. Once I do that, I look for like terms. What do I see as my like terms in there? N squared does not have a like term. Well, -4 and -4, and well, -4n and -4n, they are like terms, so I can combine them. -4n minus 4n is actually -8n plus 16. That's your answer. It was actually not that bad. It was all about you being able to figure out how to divide fractions. Yeah? Did you understand this?
Yeah.
Okay, so let's go back. Let's try number 2. Number 2 looks like a big time one. It looks a little harder, but it is something that we already worked with. So for number 2, right? You can obviously do both the methods, the first and the second one, where you have to make the first, so where you have to make the fractions in the top. So you have to make these two fractions into one fractions first, and then you can like do like keep change flip, or like the way you do dividing fractions. You can obviously do that. If you want to do that, go that way. Or if you want to do the second method using the LCD, you have to figure out what your LCD should be, because if you do not have the correct LCD, your problem is not going to be easier or simpler. It's going to be more complex than before. And obviously, it's going to be incorrect, not to mention. So take about 2 more minutes on that problem. Just by like show of hands, or like you guys can also put it in the chat. Did you guys know about the second method before, like the LCD method? You can multiply each of the fractions in the bigger fraction using the LCD, that method. Did you guys know it before? Or you can unmute and speak. Wait, so you didn't know?
Yeah, I know now.
Okay, so okay, how was there? Did you know that before?
Why?
So I'm actually talking about this one, this method. You multiply everything using the least common denominator, and then you get rid of the fraction on top of a fraction, and then it becomes nice and simple like this. Did you know about this method before?
No.
Okay. No, I just wanted to know. That's it.
Okay.
Yeah, so take about 1 more minute, get your final thoughts, and mathematical methods or steps for the second problem. And we're gonna go over that. All right, so do you guys have any answers for me yet, or you guys want to go over? You guys need some more time?
Could we go over it?
Sure, we can. How about Razor? What do you want to do?
Go over it.
Sure. So this problem is also not that bad, actually. And I'm saying that because there are harder problems than this one. But this one is not that bad because the denominator is not a fraction, which is why I said that. Okay, anyway, so do you guys have a choice? Like, which one should I do first? Method 1, method 2?
Which one's the easiest?
Well, for me, method 2 is the easiest, but I can obviously show you method 1. Mike, do you have a preference, or are you just okay? So I'll do both ways. Let's start with method 1 first. So in method 1, what you have to do is that you obviously have to combine these two fractions into one fractions, and obviously the way you do that is by finding the common denominator. So what do I have to multiply b plus 3, a squared over b plus 3 with, so that it's going to have the same denominator as the other fraction? Thank you for answering. It is a. And then you multiply the other fraction using b plus 3. Because now you have the same denominator. And we want that if you have the same denominator, then you can just combine the numerators. And then I'm going to bring the denominator of this bigger fraction, right? So once you do that, what do you have? Well, in my top, I have a times b plus 3. Please, please, please do not forget the parentheses around b plus 3, because if you do that, if you forget, then it's just like a times b plus 3, which is totally different from whatever I wrote in there. So please do not forget the parentheses. And now I multiply across. A times a squared times a gives me a to the third. And now 2 times b plus 3 gives me 2b plus 6. Yeah. And then when you do that, you are dividing fractions. And how do you divide fractions? Well, I keep the first fraction, or the numerator in there, and then I flip the other fraction. And now what? Now what do you guys see? What should be my next step from there? What should I be doing here? So like, literally I'm stuck here. What should I be doing now? Well, now I try to like look for common factors that I can probably or potentially cancel out. Do we see any common factors? Please do not tell me that you can cancel out this thing and this thing, because I can't. You can't cancel out the a squared with the a cube in there. That is no. So then what should I be doing here if I do not have any common factors that I can cancel out? Well, then that is it. There is nothing that I can do. I have to multiply across. So if I multiply across, the top gives me whatever it was, because anything times 1 is just itself. And the bottom gives me, so you guys see how I have, okay, so how do you multiply this? You can combine that. How do you, like, what do you combine in there?
The A's.
Yep, and how do you combine them?
You multiply them.
And how do you multiply? So if you have a times a squared, what do you do? Yep, it is a cubed. You keep the base because you have the same bases that are being multiplied, and you add the exponents, and 2 plus 1 gives you 3. So it's going to be, so if I multiply this across this part, I should get a cubed times b plus 3. And guess what? That is your final answer. You cannot simplify this anymore. So that is that. We're going to try one last problem from there. Try this problem in here. Oh, I forgot to ask you guys. You guys want me to use the other method for this one? The LCD method, or no? I mean, okay, so for LCD method, right, if you are trying to use the second method, what you have to do is that you have to multiply everything using b plus 3 and a. Because if you take a look at that, that is your LCD. If you take a look at the denominators of the smaller fraction, that is your LCD, right? So then if you multiply everything in there using that, so I'm going to multiply this using that as well. So I multiply that with a and then b plus 3. And I multiply this part using a times b plus 3. And what happens when I do that? Well, the thing that happens is that, so let's work with this part first. Right? So the b plus 3 and then b plus 3, they cancel out, right? So I'm just left with a squared times a. And what is a squared times a? Well, a squared times a is a cube, like we just did, right? And now if you try to take a look at this part, right there, so now I will be able to cancel out the a and this a, right? And now whatever I'm left with, I multiply across. 2 times b plus 3 gives you 2b plus 3 parentheses, or you can write that as 2b plus 6 if you prefer. And now whatever I have at the bottom, so at the bottom I have a squared times b plus 3 times a. That gives me a cube times b plus 3. And in the top, what you have to do is that that is exactly what we had as our answer for this exact problem. I mean, you could have like done it like from this to like exactly this step. So this is like a one-step problem if you did it that way. So that's why I kind of prefer this method, because you can directly come to the answer without doing not as many steps. So let's move on. I was asking you guys to do this problem. For this one, I would kind of like recommend you guys use the second method of LCD. It's gonna get much easier if you do that.
Wait, what did you say?
Oh, I told you to do this problem, but I said that I probably would recommend using the second method of like LCD, like multiplying all the fractions using the smaller fractions using the LCD. I mean, if you obviously do not like that method, you can use the first method, but I cannot recommend that second one. But doesn't matter, just do any of which you want, and then send me the answer. And please, please, please do not get confused. This is U and this is V. They look so similar, and I hate this kind of problems, but they're different. Please do not get confused with them. Let me know if you guys are stuck, confused, or anything.
I'm stuck.
Okay, no problem. Thank you for letting me know. Meg, do you want to go over, or do you need some more time to yourself?
Could go over.
Yeah, but for this one, what I'm gonna do is that I'm gonna ask you guys to walk me through. So what should be the first step that I should be doing depending on the method that you choose? So if I'm trying to do, I don't know if you guys want to do method one, if what should be my first step for method one? If you guys want to do method two, what should be my first step for method two? Communicate with me, talk to me.
Find a common denominator.
Yep. So are you trying to do method one or two?
I forgot which one is which.
So you are trying to find the common. Oh yeah. So if you're trying to do common denominator, then it's method one. So I know what you are trying to do is that, okay. So you don't have to do anything to the top, right, Maggie?
Yeah.
So the top is gonna stay like that because I do not have fractions being added or subtracted. But then at the bottom, Maggie just told me that I have to create the common denominator. And how do I create the common denominator? Well, I know that if I multiply this fraction using 2, and if I multiply this fraction using u squared, then I'm going to have the same denominator, right? Which is what we always try to do. So I have u squared over 2v, and then at the bottom I have the same denominator, 2u squared, and then whatever I have, I multiply across. So 2 times v squared gives me 2v squared, and then v times u squared gives me plus vu squared. And now what do we do? What is our next step? How do you divide fractions? Thank you for telling me that. It is, you keep it, change it, flip it, or in other words, you multiply the numerator using the reciprocal of the other fraction. So u squared, oh, okay, this looks, no. So u squared over 2v times the 2u squared that goes in the top, and then the 2v squared plus vu squared that goes in the bottom. And now what do? You look for common factors. Do you guys see any common factors that you might cancel out?
2v. No.
You can cancel out. You can cancel out the 2? Yep. What else can you cancel out? So you actually cannot do anything to this fraction anymore, and this is gonna be your final answer. So u to the 4th over whatever you have in here, you multiply across. So you have. So you can actually keep them like this. Or you can obviously distribute them, which is u to the 4th over 2v cubed plus v squared u squared.
Wait,
That is your final answer.
That's a VV or that's a VW?
Which one are you talking about?
Like with the V parenthesis 2V squared plus VV.
Oh, no. This is a v and this is an u.
Oh, okay.
I apologize for that. Yep. Do you guys have any questions? These were actually easy so far. It was not like that bad actually. Now I'm gonna tell you about the other method, which was using the LCD. Jay, if you're done.
Yeah.
Okay. So in here, if you take a look, right? So my LCD. Okay, I'm gonna clear. So in here, it is actually a little weird because you have a fraction in the top and 2 fractions in the bottom. And now what you have to do is that you have to take a look at the denominators. You have 2. You don't have to care about numerators. Just take a look at the denominators. You have 2, you have u squared, and you have 2v. I'm going to write them in here. So you have 2u squared, and then you have 2v. These are the 3 denominators you have. Well, the LCD is actually going to be 2v u squared. So I took the v, I took the u squared, and I took one of the 2's. I cannot take 2 of the 2's because once you take one of the things, you don't have to take the exact same thing again. So if you try to take a look at the denominators, you have 2 and then you have 2. Well, the LCD of 2 and 2 is not 4, it's just 2. The same way the LCD of 3 and 3 is not 6, it's just 3. You don't multiply them. And then it just like it's the same thing, right? So you just take one of them. You don't have to take 2 of them. Okay. So if this is my LCD, which I figured out just by looking at the denominators, right? So then I'm gonna multiply everything using 2v u squared. Multiply this using 2v u squared. Multiply this top using 2v u squared. And guess what happens when I do that? You can cancel things out. You are going to get rid of all the denominators that you have of the smaller fractions. All the smaller fractions are going to lose their denominators. Look, you have 2v in there, so 2v cancels out the 2v with there, right? So then you are just left with what? U squared times u squared is u to the 4th, right? And then in the bottom you have the u squared cancels out with the u squared in there. Boom, you just lost that denominator, no more fractions. And then 2v times v squared gives you what? 2v to the 3rd, right? And if you take a look at this part, this 2 and then this 2 are going to cancel out. Boom, no more denominators. So v times v times u squared gives you v squared and then u squared. And guess what? That was exactly your answer. Now you just took you one step to do this problem. Bingo. So Do you guys have any questions?
No.
No.
Any concerns, comments, anything about today's lesson? No?
No. Are we done?
If you, yep. If you don't have any questions, concerns, or comments, then we are done for today. And I'm going to see all of you or whoever is in here today tomorrow at 5 o'clock.